All right, hey, this is Mr. Barr, and this is relations versus functions. So what do we got going on here? We've got, I can use functions to model real-life situations. Functions are just fancy equations that do work for us and help us understand the world. I want to understand and create functions. Do you know the difference between a dog and a German Shepherd? What? That's kind of a weird question because a German Shepherd is a type of dog. Let's get even weirder. Do you know the difference between a function and a relation? It's similar to the dog question. By the end of this lesson, you'll be able to identify a function and a relation. And just like a little preview, everything we're going to look at is a relation, but not everything is a function. Okay, so let's get going here. Getting those notes ready to go. So we can start with the title of our notes, which is Relations versus Functions, and our name. Relation versus function. A relation is just a relationship between x's and y's. This part is going to be a little bit dry, but we're going to write that into our notes. A relation is just a relationship between numbers, x's and y's. A function is a very specific relationship where each x gets one y. So in our notes, a relation. A relationship between numbers, x's and y's. So when I just give you a whole bunch of points in a table, in a graph, in any form, it's a relation. So just a bunch of points, doesn't have to have any order to it. It's just a bunch of points, it's a relation. A function get rid of the word a. A function is a set of points where each x gets only one y. So relation is a relationship between numbers, just x's and y's, so random points. And this is a very specific relationship where each x gets one y. So I'm going to show you three different mapping diagrams here, and then we'll get into our notes. So this is a relation, but not a function. So I've got 0, -2, 0, 1, 1, 2, 2, 1, 3, 4. This is a relation, it's just a bunch of points. This is a relation, it's just a bunch of points. This is a relation, it's just a bunch of points. But some of these are functions and some are not. This is not a function. Remember the definition, each x gets one y. Well, if this is x, if he's 0, he took two y's. 0 reached out and grabbed two y's. This is not a function. X grabs a -1, that's cool. 9 grabs a -3, that's cool. 10 grabs a -1, that's cool. Each x gets one y. Each x gets one y. Here, this is cool. -2 takes a 4, 2 takes a 4. Each x gets one y. Each x gets one y. Once again, a function. So here's my candy analogy. I know it's not Halloween when you're watching this, but it's October when I'm making this. So it's kind of cool that I'm wearing a costume. Okay, so here's my candy. Which way do I have to face to hold my candy thing? Oh, I'm gonna go grab my candy. Oh, there it is. I'm trying to grab the candy. All right, so here's the deal. Imagine I got this big bowl of candy and I come to class and I say, everybody gets one candy bar. Everybody gets one candy bar. So I walk around and let's see, who's in my class right now? I'm going to try to use names that are actually people in my class. Really, with my paper. Here it is. Who's in this class? There we go. And I say, hey, Tianka, have a candy bar. And Tianka says, okay, I have a Twix. And everything's good. And I come over to Ezekiel and I say, have a candy bar. And Ezekiel takes a Snickers. And I come over to Lorianne and I say, have a candy bar. And Lorianne takes a Kit Kat. And then I come over to Griffin. I say, have a candy bar. And Griffin takes, what does Griffin take? He takes the Three Musketeers. Everything's good, right? Each person's taking one candy bar. And then I come over to Dakota. And I say, Dakota, take a candy bar. And you know what Dakota does? She grabs the Reese's and a Snickers. No! Dakota, no! That's not cool. You took two candy bars. You only get one candy bar. So right there, Dakota shows what not a function looks like. One person can't take two candy bars. One X can't take two Y's. But let's go to somebody else in our class. Let's go to Lily. And Lily says, you know what, Mr. Barr? I'm really not that hungry. Can I just share some M&Ms with Talise? And I'm like, yeah, that's cool, man. No one's going to get upset if you do that. I mean, you're going to share, like, the M&Ms. That's all right. That's all right. You didn't take two candy bars. You're just sharing the candy bar with somebody else. That's cool. Sharing is caring. Being greedy is not a function. Sharing is a function. One person, one candy bar, that's a function. One person, two candy bars, not a function. Two people sharing a candy bar, that's just fine. So what does that look like in our notes? Let's do this. It's a good lesson, isn't it? It's because I'm wearing a hat. It's also that I'm almost done for today. Okay, so what does this look like? When we really do this, what does it look like? So in our notes, I'm going to show you a function. 1, 2, 3, 4, 5, 6. This is a function. Excuse me. Notice nobody's getting greedy. 1 is taking a 4, 2 is taking a 5, 3 is taking a 6. This is a function. Let's show another one. This is okay. This is sharing. Oh, 1 and 2 are sharing the M&Ms. Yeah, that's okay. Nothing wrong with that. This is sharing. Sharing, yes, a function. You know what's about to happen. I'm going to give you the not a function. No, this is not a function. space. Why is it not a function? Because 1 is getting greedy. 1 is taking 3, 1 is taking 4. So yes, a function. Everybody gets 1, everybody gets 1. Yes, a function. These guys are sharing. Not a function. 1 is getting greedy. So I think in this form, it's pretty easy to tell which one's a function and which one's not. The thing is, it's not always going to be given to us like that. So here it is in a mapping diagram. But remember, these are just points. And points can be given to us in a table. Points can be given to us in a list. Points can be given to us in a graph. So let's look at this. Is this a function? Yes, it is. 3 is taking 6. Everybody's just taking 1. This is a function. Yes. Is this a function? Is this a function? No. Look at 11. 11 is being all greedy. Greedy 11. This is not a function. Is it a relation? Yes, it's a relation. Everything we're looking at today is a relation. But this is not a function. Is this a function? Yes, this is a function. I know you're looking at this one and this one. They're just sharing. This is the M&Ms, and they're sharing it. This is a function. Is this a function? This could be shown as a mapping diagram. I could absolutely take it, and I could draw it like this, and I could go 4 takes the 5. I could go 5 takes the 6. I could go 7 takes the 8. And I could go 9 takes the 10. I could totally draw a mapping diagram out for everything, but I can just look at it. 4 takes the 5, 5 takes the 6, 7 takes an 8, 9 takes the 10. Yes, this is a function. Is it a relation? Yes, it's a relation. They're all relations. Is this a function? Let's look at this. Let's see. 4 takes the 5. That's cool. Uh-oh, 4 takes the 7. Right here, you see that? 4 takes the 5. 4 takes the 7. No, that's not cool. Number 4, you're so bad. No, number 4. No, no, no. Is this a function? Well, let's look at it. 4 takes the 5. That's cool. 6 takes the 7. What I'm doing is I'm looking for 6 again. 5 takes the 4. That's cool. Negative 2 takes the 5. That's cool. Nobody's taking 2. Now, I do get right here, see these two guys? What are they doing? 4 is taking 5. Negative 2 is taking 5. Oh, they're sharing. They're sharing the M&Ms. That's happy. They're good. They can share the M&Ms. We're so happy. I'm sharing an M&M with you. We're friends. Okay. Oh, but now what's going on? Now it's like a graph. Confused. Well, these are just points, aren't they? Isn't this negative 1 comma 3? That's cool. Isn't this 0, 1? That's cool. Isn't this 1, 2? That's cool. 3, 4. Let's see. Negative 1 takes 3. 0 takes 1. 1 takes... Yep, that's cool. That's a function. It's just a bunch of points. Is this a function? Let's see. Let's see. This is negative 1 comma 3. This is 0, 1. This is 3, 2. This is 3. Uh-oh. 3, negative 2. What are you doing, number 3? Look, number 3 is taking a 2 and a negative 2. Number 3 is being selfish. Don't do that, number 3. But I'm going to give you a hint here. I knew that right away just looking at the graph. Anytime I see 2 points that are right on top of each other, I know it's not a function. Right there, 2 points right on top of each other, it's going to be like 3, 2, 3, negative 2, not a function. Look at this. Is this a function? We'll go back to here. If I see 2 points on top of each other, I know it's not a function. Well, do I have 2 points on top of each other anywhere? A point, a point, a point, a point. Do I ever have a point right on top of another point? Are you confused by what I mean, 1 point right on top of another? 1 point right on top of another point. So, no, I don't have any points right on top. Is this a function? We'll see. There's a point right here. And you know what? There's a point right there. And those points are right on top of each other. So no, this is not a function. Which leads us into the next topic for today, which is called the vertical line test. So let me open up the vertical line test. Let me pause this. I'll be right back. All right, so I'm back here, and we've already figured out that if I have 2 points right on top of each other, it is not a function. And right here, I can go a point on top of a point, not a function. 2 is taking 4, 2 is taking -4. 2 points right on top of each other, not a function. Well, here's how the vertical line test works. If I draw a vertical line through a graph and it touches it in 2 or more places, it is not a function. What it's really saying is, hey, I'm drawing a vertical line. If it touches it in 2 places, that means there are 2 points right on top of each other. So let's get this into our notes, the vertical line test. So it's called the vertical line test. If a vertical line touches the graph in 2 or more places, then it is not a function. If a vertical line hits the graph in 2 or more places, then it is not a function. So what does that look like? So I'm going to give you some different shapes here. We're going to need 3 coordinate systems. Coordinate system, coordinate system, coordinate system. Three different graphs. So what I do is I draw a vertical line. Ready? Boom, vertical line. Hit it in one spot. One spot, one spot, one spot, one spot, one spot, one spot, one spot. This is a function. Vertical line, ready? Boom. 2 spots. Not a function. Hits it once, function. How about this one, ready? Boom. 1, 2, 3, not a function. That's how the vertical line tests work. What it's really saying is, hey, look, there are points on top of each other, it's not a function. It's saying, hey, look, there are points on top of each other, it's not a function. Hey, look, no points on top of each other, it is a function. So let's look at some of these. Not a function. Boom, it hits it twice. This guy, is it a function? It's totally a function, right? If I draw a vertical line, boom, hits it one time. Vertical line, hits it one time. Vertical line, hits it one time. It's a function. This one, right? Boom, vertical line one time. Vertical line one time. It's a function. This guy, boom. Vertical line 2 times, not a function. Vertical line 2 times, not a function. This guy. Vertical line 1 time, function. Vertical line 1 time, vertical line 1 time. It's a function. Ooh, and this is my favorite one. Vertical line 1 time, not a function? No, you got to go find the area. Go look for it right there. So you got to go across the whole graph. You can't just say, oh, look, it's a function. Oh, look, it's a function. No, you got to go find the area where it's not a function. This is not a function. This one, vertical line, boom, hits it twice. Vertical line, hits it twice. Not a function. And that's it. Thank you for watching. Have a great day.